In this video here, we're going to take a look at integration using partial fractions. Now, we saw as part of the A-Level Maths curriculum how we could use partial fractions to integrate more complicated expressions. And what we want to do now is take that idea and build on it further with ideas that we introduced in the previous video on integration with inverse trigonometric functions. So let's just work through an example here demonstrating this concept. So let's just have a go then at this one practice question here for integration using partial fractions. So for this question here, we want to show that the following integral here is equal to this result where c is just an arbitrary constant. So to get us started here then, clearly the first thing that we should do is split this algebraic fraction up here into partial fractions. So we have 2 minus x all over x times x squared plus 4. Okay, so if we split this up into partial fractions then, given that the factors here of the denominator are already in their simplest form, what we obtain here then is ax plus b. So ax plus b all over x squared plus 4. Like so. And then for the factor of x here, we get c over x. So plus c over x there. Okay. So now for the right-hand side here, right, as you should be very much familiar with by now for partial fractions, what we need to do is get this over a common denominator. And in doing so, we obtain x times ax plus b. We then have c times x squared plus 4. So plus c times x squared plus 4. Okay. So at this point here, now this would be over a common denominator of x times x squared plus 4. And hopefully then you recognize that this is the exact same denominator as the left-hand side. So what that means then, given that the denominator of the left-hand side is equal to the denominator of the right-hand side, in that case then, the numerators must also be equal here. So this expression here is equal to 2 minus x, right? That's just the numerator of the left-hand side. So what we now need to do here is find the value of a, b, and c. So to get us started then, if I let x equal 0 here, then in that case, this term here would just be 0, right? Because I've got 0 times ax plus b, where x again is just 0. So this term here is just 0. And what that means is we've eliminated a and b, and we can now go on to solve for c here. So in that case, then we get c times 0 squared plus 4. I get 4c is equal to 2 minus 0, which just gives us 2, right? And in that case then, if we just solve for c here, we obtain a half. So we found the value of c, we now need to find the value of a and b. So to find the value of a and b, what we now need to do is equate coefficients. So let's just make a note here. So we now equate coefficients here. What I'm going to do here then is start with the coefficients of x squared. So now equate coefficients for x squared. So if we now equate coefficients for x squared here, well, I've got ax times x. So imagine you expand this out, we get ax squared. So the coefficient of ax squared is just a, right? So I've got a. What else do we have here on the left-hand side? So we expand this bracket here with the c on the outside, I get cx squared. So the coefficient of cx squared is c. So on the left-hand side, we have a plus c. Nothing else we can do with the left-hand side here. So now what about the right-hand side? Well, the coefficient of x squared here for the right-hand side is just 0, right? We have no x squared term. So a plus c is equal to 0. So in that case then, given that we already know the value of c here, a must be equal to minus a half, right? Hopefully nice and straightforward there. And then to finish with here, what we now need to do is equate coefficients for x. So again, let's just make a note here that we're now equating coefficients for x. Okay. So what can we do with the left-hand side here? So I've got x times b, that gives me bx. So the coefficient there of bx is just b. Nothing else we can do with the left-hand side here, right? And then for the right-hand side, the coefficient of minus x here is minus 1. So equating coefficients then for x, we obtain that b is equal to minus 1. Okay, so we find the value of a, we find the value of b, we've also found the value of c here. So what we can now do is rewrite this integral here using our partial fraction decomposition. Okay. So in that case then, we have the integral here. Hopefully I can just about fit all of this on here. So the integral of 2 minus x all over x times x squared plus 4 with respect to x. So in this case here then, using our partial fraction decomposition where we find the values of a, b, and c, right? As you can see here, what I'm going to do to begin with then is rewrite this fraction. I'm going to split this up into 2 fractions. Okay. I'm also going to apply linearity here. So for the a, or for this value of a here, that is minus a half, what I'm going to do here is take that outside the integral using linearity. We get minus a half then times the integral of x all over x squared plus 4. Okay, I'm integrating here then with respect to x. I've got minus a half times the integral of x over x squared plus 4 with respect to x. Yes, that was ax over x squared plus 4 there. As I already mentioned, right, just applying linearity then, we take the a value outside. So minus a half outside the integral. Moving on then, so we now have b over x squared plus 4 here. So given that b is equal to minus 1 then, nice and straightforward here, we just simply get minus the integral. So minus the integral then, so b is, b is equal to minus 1. We've got minus the integral then of 1 all over x squared plus 4. Okay, again, integrating with respect to x here. And then finally for the c over x here, well, given that c is equal to 1 over 2, again, I can just apply linearity here. So we get plus 1 over 2. So plus 1 over 2 times the integral then of 1 over x here. Okay, and again, we're integrating with respect to x here. So now all we need to do here is evaluate each one of these integrals separately. So just take your time with this, right? We can easily make a mistake here if we're not careful. So for the first integral here then, just notice that if I differentiate the denominator, I get 2x. My numerator is x, so we're pretty close to the required form here. All I need to do here is take a factor of a half outside. So in that case then, what I get here is minus 1 over 4. So minus 1 over 2 times 1 over 2 gives me minus 1 over 4. And then we get ln of my denominator, right? So minus 1 over 4 ln of x squared plus 4 here. Like so. As I go, by the way, I will leave the constants of integration until the very end, right? And just leave that as just plus c at the very end. So we get minus 1 over 4 ln of x squared plus 4 for the first integral here. Now for this integral here, hopefully you recognize then that this involves the inverse trigonometric functions, right? So this integral here is of the form then of 1 over a squared plus x squared, which if we integrate this here with respect to x, this will be equal to 1 over a arctan of x over a. Okay, so in that case then, what we get here is minus 1. Well, a squared is 4, so a is 2, so I get minus 1 over 2 arctan of x over a, so that's x over 2. Nice and straightforward there. And then finally here, this integral here should be nice and straightforward. I simply get 1 over 2, so plus 1 over 2 ln x. Okay. And at the very end here then, don't forget our constant of integration plus c. Okay. So what I'm going to do here then is, because I can see, the final solution here is combining these logarithms, these natural logarithms here. So let me just rewrite this here then. Put in the ln x at the front here, given that that's positive. So I get a half ln x, a half ln x. I've then got minus 1 over 4 ln of x squared plus 4. Like so. And then we have minus 1 over 2 arctan of x over 2. Okay. Don't forget plus c here, our constant of integration, just an arbitrary constant, right? What we can now do is factor out a 1 over 4 here for these two natural logarithms, right? And we're going to get it into this form here, basically. So, factoring out the 1 over 4, I get 1 over 4. Now, inside the bracket here, we're going to get 2 ln x. We get 2 ln x. We then get minus ln of x squared plus 4, right? Because we've factored out the 1 over 4. So minus ln of x squared plus 4. Like so. Close that bracket. And then again, we've got minus a half arctan of x over 2 plus c. Let's write this down in full. X over 2 plus c. Then we're pretty much done at this point, right? So we could just write this as ln of x squared minus ln of x squared plus 4. And then writing that as a single logarithm here as a quotient. As we can see here, we obtain 1 over 4. So we get ln of, so I get x squared, just using the power rule here for logarithms. So x squared all over x squared plus 4. We then have minus a half arctan of x over 2. So minus a half arctan of x over 2 plus c there, exactly as required. So as required then. And there we have it. So that gives us the solution there. So this one practice question for this video. As you can see, these questions can be quite lengthy and quite easy to make a mistake on. I can assure you I've made many mistakes myself writing these questions and kind of filling out solutions and stuff. It is really easy to make just tiny little mistakes, but hopefully nothing too challenging there. Okay. So there we have it. That gives us the solution to the one practice question for this video here. And that actually brings us to the end then of this video here on integration using partial fractions.